This is the second problem on the Newton's second law problems worksheet that we've been doing in class. In this problem, an object is being pulled via a rope as shown. The coefficient of friction between the box and the ground is 0.25, and we're trying to find the acceleration of the box, and we're also going to find the normal force. And we have to find the normal force along the way in order to find acceleration, because anytime you have a problem with the coefficient of friction, we're going to need to use the normal force to solve for the force of friction, which we'll need to get acceleration. So the first thing we'll do is try and solve for the normal force. In this problem, the normal force is in the y direction, and it's in the positive y direction, so I'm going to write that down as positive. I have another arrow that goes upward. Tension here goes at an angle, so I have part of it that goes to the right in the x direction, and part of it that goes upward in the y direction. And because it's upward, that part is positive in my equation. Then force of gravity is downward, so that's minus. And there is no acceleration in the up and down direction. This is accelerating on the x-axis to the right. So in the y direction, there's no acceleration, so I can just write that that all equals 0 when we add it up, because all the forces added up equal mass times acceleration. With no acceleration, that just goes to 0. Rearranging, we can solve for the normal force. And the normal force will equal the force of gravity minus the tension in the y direction. To solve, we have to plug in our numbers. Force of gravity, as always, equals the mass, which is given right here as 5 kilograms, multiplied by the acceleration due to gravity, which is always 9.8 meters per second squared here on Earth. Now we have to subtract this tension in the y direction. So if we take a look at our triangle that's made out of our tension force, the tension in the y direction is the opposite side. So it's the opposite side of our 25-degree angle. So that means we're going to be using the sine in order to find that. So that's why we're going to write down the sine of our angle, which is 25 degrees. And I have to multiply that by the actual tension force, the hypotenuse of that triangle, which is 50 newtons. Once I do all of that, I can plug it into my calculator, and I find that the normal force is 27.87 newtons. So that's the first thing we were looking for, and there it is. Now we can use that to find our force of friction, and we'll have to find our force of friction in order to find out what the acceleration of the box is. So solving for friction, just so that we have it, our equation is the force of friction equals the coefficient of friction multiplied by the normal force. Now we know both of those. Our force of friction is going to equal the coefficient, which is 0.25. And that's going to be multiplied by our normal force, which is 27.87. And when we plug that into our calculator, what we will get is that the force of friction is 6.97 newtons. So that's where that will come from when we plug that number in for finding acceleration. So now let's find the acceleration of this box. So we're going to add up our forces that go to the right, which is just tension in the x direction, minus any force that goes to the left, which is friction. We're out of forces that go along the x-axis, so that's going to equal m times a, because that's Newton's second law. All the forces added up equal ma. From here, tension in the x direction, that's the adjacent side of this triangle. So I'm going to use cosine of the angle, which is 25 degrees, times the hypotenuse of the triangle, which is 50 degrees. 50 degrees, 50 newtons, minus our force of friction, which we just solved for down here using the coefficient and the normal force. So that's minus 6.97 newtons. And that's going to equal our mass, which is 7 kilograms. I'm sorry, 5 kilograms. Looking at the wrong thing. That's equal to 5 kilograms multiplied by the acceleration. Now all we have to do is divide by our 5 kilograms, and we are good to go. So my left side remains unchanged, cosine of 25 degrees times 50 newtons minus our friction, which is 6.97 newtons. Divide our mass of 5 kilograms over, and that will give us acceleration. And once we plug all of that into our calculator, we get that 7.67 meters per second squared is equal to the acceleration of the box. So the first thing we had to do was solve for our normal force. We did that by taking our upward force plus our other upward force, which is tension in the y, minus force of gravity. Solve for normal. Use that down here to solve for our force of friction, so that when we added up our forces in the x direction, tension to the right, friction to the left, that all equaled ma. We plug in what tension in the x is, what we found for friction, ma, divide by the mass, and we get our answer. And that's how we do problem number 2 for the Newton's second law problem worksheet.